Let us take one concave mirror and one convex mirror. This is concave mirror and this is convex mirror. Geometrical center of the mirror is called pole. Center of the whole sphere, glass of sphere, is called center of curvature. The line passing through center of curvature and pole is called principal axis. When parallel beam of rays are falling on concave mirror, all the parallel rays will converge at one single point, that is called focus. After reflection, all these parallel rays are meeting at one single point, and that point is called focus. In case of convex mirror, the parallel beam of rays, instead of converging, they will diverge. They reflect in such a way that they appear to be diverging from one point. They appear to be diverging from one point, and that point is called focus. So when it comes to concave mirror, you need to understand that both focus and center of curvature are in front of the mirror, whereas in case of convex mirror, both focus and center of curvature are behind the mirror. Okay. Now, what is the relation between radius of curvature and focus? You have to understand that focal point is midpoint of CP. F is midpoint of CP. That means distance from center of curvature to pole is radius of curvature. Center of curvature to pole, the distance is called radius of curvature. At the same time, distance between pole and focus, the length between pole and focus is called focal length denoted by F. In both the cases, this is the midpoint. From pole to center of curvature, that distance is called radius of curvature. From pole to focus, the distance is called focal length. Got it? So focal length is half of radius of curvature. If you cross multiply, radius of curvature is twice the focal length. This is the relationship between focal length and radius of curvature. Got it? Once again, this yellow line, that is distance from the pole to focus, this length is called focal length. This green line from pole to center of curvature, is called radius of curvature. Okay, if you double the focal length, you will get radius of curvature. For example, center of curvature, focal point will be exactly in the middle. This is principal axis. Now, can you tell if the focal length is 5 centimeter? If the focal length is 5 centimeter, can you tell what is radius of curvature?
10 centimeter.
Yes, it's as simple as that. Double it. Okay. So radius of curvature you will get radius of curvature on multiplying with 2 to the focal length. Double of focal length is radius of curvature. If the radius of curvature of a mirror is 20 centimeter, can you tell what is focal length?
10 centimeter.
10 centimeter. Half of radius of curvature. Focal length is nothing but half of radius of curvature. This is the relationship between focal length and radius of curvature. The distance from the pole to center of curvature is called radius of curvature. From the pole to focal point is called focal length, and focal point is exactly in the middle. Okay, so that's it for this concept. This is the relation. Okay, let's go to the next concept. Is this concept clear? And the concave mirror is called converging mirror. Why it is called converging mirror? It is called converging mirror because it converges all the parallel rays after reflection at single point. Here actually the temperature will increase. Why? Because all the rays are meeting here. At this particular point, the heat will increase. Okay. If you put a paper here, a piece of paper here, it will burn. Okay. So now let's go to the next concept, which is so here there are 4 rules to draw ray diagrams of concave mirror. So I will be explaining through the diagram what are the 4 rules, and please note that first we are trying to draw find the rules to draw ray diagrams of concave mirror. Later on I will teach rules for convex mirror. Okay, now let's start rule number 1. Rule 1. So this is concave mirror, reflecting surface at the back of the mirror. This is pole, center of curvature. In the middle you'll have focus, the line passing through center of curvature, and pole is called principal axis. Okay. Now the first rule says that any ray parallel to the principal axis, after reflection, it passes through the focus. This is the first rule. If the ray is parallel to principal axis, after reflection, it will pass through focus. The ray need not be coming from the top of the principal axis. From the below the principal axis also, you can draw a parallel line, ray of light parallel to principal axis. After reflection, it will definitely pass through the focus. You can even draw the diagram like this. Okay. But always remember, incident ray direction and reflected ray directions are must. These arrow marks will show the direction of the ray. So what is the first rule? Any ray parallel to the principal axis, after reflection, it passes through the focus. That's it. Okay, let me write the rule. Please note down the rule. A ray which is a ray of light which is parallel to the principal axis passes through the focus after reflection. Got it? Got it, girls? Shall I go to the next rule?
Yes, sir.
Yes, sir.
Okay, rule number 2. In the next page, let's start rule number 2. Again, draw a concave mirror, reflecting surface. Pole, focus, center of curvature, principal axis. The second rule, the next rule says that any ray passing through center of curvature, any ray passing through center of curvature will move back in the same direction, same path. After reflection, it will move back, it will reflect back along the same path. जैसा रे आया वही डायरेक्शन में वापस चले जाएगा अगर वो सेंटर ऑफ कर्वेचर से पास हो रहा. Got it? So let me write the rule. A ray of light passing through the center of curvature will reflect back in the same path. It will go back in the same path. Is that okay? This is our second rule. I told we have 4 rules. If you are perfect in these rules, you can draw all the ray diagrams of mirrors. This was the first rule. Ray parallel to principal axis passes through focus. A ray passing through center of curvature will move back in the same direction. Now let's go to the third rule. Shall I go to the third rule now?
Yes.
Okay then. Rule 3. Draw again a concave mirror. Make a habit of drawing any diagrams reflecting surface. You can use scale to draw principal axis. Now this is pole. Geometrical center of the mirror is called pole. Center of the spherical glass, hollow sphere of glass is center of curvature. Focus is located exactly at the center, middle of CP. Principal axis passes through center of curvature and pole. A ray passing through focus. A ray passing through focus after reflection, it will become parallel to principal axis. Any ray passing through focus after reflection, it becomes parallel to principal axis. It becomes parallel to what? Principal axis. You can even draw the figure like this. You can even take the ray from the bottom. Any ray passing through the focus, that ray will become parallel to the principal axis after reflection. You can draw the diagram from the bottom like this. But generally we draw this way. A ray passing through focus after reflection, it will become, this is reflected ray, this is incident ray. Okay, fine. This is third rule. I'm writing the rule. Please note down. A ray of light passing through the focus becomes parallel to the principal axis after reflection. Okay, third rule, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then rule number 4 and the last rule. Draw a concave mirror, reflecting surface, pole. You can use scale while drawing this principal axis. Center of curvature, focus, principal axis. Principal axis is an imaginary line, it's not a ray. Now, any ray incident on the pole, any ray incident on the pole, what happens? It will reflect, making same angle with the principal axis. It will reflect making same angle. What angle it made initially, the same it will make after reflection, it will make the same angle. It will reflect back at the same angle with the principal axis. If it is incident at 30 degrees, making 30 degrees with the principal axis, it will make 30 degrees with this principal axis and it will reflect. It is not like it is making 30 degrees while incident and it is making 60 degrees while reflection. No, it's not like that. It makes same angle with the principal axis after reflection. This is our fourth rule. I will be writing. Please note down. Fourth rule. A ray of light which is incident at the pole of a concave mirror no need, anyhow we are considering concave mirror, so no need to mention. Will reflect back making same angle with the principal axis. Okay, these are the 4 rules which will help us to draw ray diagrams for concave mirror. Clear? Now let us discuss few important things. For example, this is the principal axis. This is the principal axis. This is focus. This is pole. And this is center of curvature. For example, if I flash a ray, if I pass a ray along the principal axis, what happens? If I'm passing a ray, if a ray is falling on the concave mirror in the direction of principal axis, can you guess what happens? Can any one of you guess what happens?
Sir, it
Will
will move back.
direction.
As it is passing through principal axis, it will move back in the same direction. If it is coming through the principal axis, it will reflect back in the same direction. 2 rules will support here. One is the ray is passing through center of curvature. It has to move along same path. And the second is it is falling on the pole at 0 degrees. It has to move back at 0 degrees, making 0 degrees. Through these two rules, we can say that if a ray is focused, if a ray is passing through in such a way that along the direction of the principal axis, it will incident on the pole and it will return back along the principal axis. Got it? This is a special case. Sometimes they ask this question. Okay. These are the rules. We'll continue ray diagrams in the next class. Directly we'll go to the ray diagrams one